Where we place equipment inside our facilities has a direct impact on information security. Control A.7.8 of ISO 27001/2022 addresses equipment siting and protection, requiring organizations to site and protect equipment to reduce the risks from environmental hazards and unauthorized physical access. In the next few minutes, we will explore what this control requires, why thoughtful equipment placement matters, and how we design secure physical environments that protect the infrastructure our information systems depend on. Let us begin by understanding the purpose of Control A.7.8 and the security risks it is designed to address. Control A.7.8 requires organizations to site and protect equipment to reduce risks from environmental hazards and opportunities for unauthorized access. Environmental hazards pose a persistent and often underestimated threat to ICT equipment. Heat, water ingress, power fluctuations, dust, vibration, and physical impact can all cause hardware failure with consequences ranging from temporary outage to permanent data loss. Control A.7.8 requires us to identify the environmental risks relevant to each location where equipment is sited and implement appropriate protections, from climate control and flood detection to physical barriers and shock-resistant mounting. The physical location of equipment within a building significantly affects its exposure to risk. Equipment near external windows is visible from outside, creating surveillance opportunities. Equipment near public areas or reception zones may be accessible to visitors. Equipment close to kitchens, bathrooms, or external walls may be exposed to water ingress or temperature extremes. We must assess each area's risk profile and site equipment in locations that minimize exposure to these threats. Server rooms and data centers have specific siting requirements under A.7.8. Raised floors allow cable management and provide air circulation while protecting against minor flooding. The absence of external windows eliminates visual surveillance from outside. Restricted access, typically enforced through electronic access control, ensures only authorized personnel can enter. The combination of these physical design choices creates an environment that significantly reduces both environmental and access-based risks to critical infrastructure. Workstation and display placement is a frequently overlooked aspect of equipment siting. Screens visible to passers-by, visitors, or colleagues in open-plan environments can expose sensitive information through visual eavesdropping, a technique known as shoulder surfing. We should position workstations so that screens face away from walkways and public areas, and supplement physical placement with privacy screen filters in high-traffic environments where repositioning is not feasible. 4 essential concepts that underpin the equipment siting and protection requirements of Control A.7.8. Environmental threats to ICT equipment are diverse and location-specific. A ground-floor server room faces different flood risks than one on an upper floor. Equipment near windows may be subject to solar heat gain. Facilities near industrial sites may face vibration or airborne particulates. Effective implementation of A.7.8 requires a systematic environmental threat assessment for each location where equipment is deployed, with controls selected and implemented based on the actual risk profile of that specific environment. Raised floors are a standard feature of professional server room and data center design, serving multiple purposes simultaneously. The void beneath the floor provides an organized routing path for power and data cables, keeping them accessible for maintenance while protecting them from foot traffic. The air plenum created beneath the floor supports hot aisle and cold aisle cooling architectures. The elevation provides a degree of protection against minor water ingress events. The combination makes raised floors a cost-effective investment in equipment protection. Shoulder surfing is a low-technology information security threat that is particularly relevant in open-plan offices, shared workspaces, and public locations. An attacker who can view a screen displaying customer data, financial information, or system credentials gains that information without any technical attack. The control is physical. Position screens away from sight lines. Use privacy filters that limit the viewing angle. Implement automatic screen lock timeouts. And establish a clean screen policy that requires users to lock screens whenever they leave their workstations. Equipment labeling and tracking serves both operational and security purposes. Labels with unique asset identifiers enable the organization to maintain an accurate equipment inventory, track the physical location of each asset, associate equipment with its authorized users, and identify unauthorized equipment that has been introduced into the environment. Asset labeling should be combined with regular physical inventory checks to detect missing, relocated, or unauthorized equipment promptly. Now let us explore the practical steps we take to implement effective equipment siting controls across our facilities. Effective equipment siting combines physical design, access controls, environmental monitoring, and asset management into a layered protection approach. Before deploying equipment in any location, we should conduct a structured site survey that evaluates environmental risks. This survey assesses proximity to water sources such as pipes, drains, and rooftop HVAC units, exposure to temperature extremes from windows, external walls, or heating systems, risk of physical hazard from vehicle access, public traffic, or nearby industrial activity, and the adequacy of the electrical supply, including surge protection and circuit capacity. The survey findings directly inform equipment placement decisions and the controls needed to protect equipment in each specific location. Physical access control to equipment areas is a foundational protection that complements equipment siting. Even well-sited equipment is at risk if unauthorized individuals can reach it. We implement layered access control using electronic access systems with unique credentials for each individual, maintaining logs of all access events, and restricting server room access to the minimum number of personnel who require it for their role. Visitor access should always be supervised, and access rights should be reviewed and revoked promptly when individuals change roles or leave the organization. Environmental monitoring provides the real-time visibility needed to detect conditions that threaten equipment before those conditions cause failure. Temperature and humidity sensors alert facilities teams to cooling system failures or unusual heat sources. Water detection sensors beneath raised floors identify leaks before they reach equipment. Smoke detectors and fire suppression systems protect against fire. These monitoring systems should be connected to alert mechanisms that reach the right people at any time of day, including outside business hours when automatic systems are more likely to catch problems before staff arrive. An equipment register that maps each physical asset to its location, assigned user, maintenance schedule, and disposal history is essential for managing the full life cycle of equipment under A.7.8. The register enables the organization to verify that all equipment is accounted for, identify equipment approaching end of life, plan maintenance activities, and respond to security incidents that involve specific hardware. The register should be maintained as a living document, updated whenever equipment is procured, relocated, or decommissioned. Let us bring together the essential points from our exploration of control, A.7.8. If you want to master all 93 ISO 27001, 2022 Annex A controls and build a certification-ready ISMS, our complete Udemy course provides detailed implementation guidance, templates, and practical examples for every control. Enroll today and take the next step toward ISO 27001 certification. Thank you for watching. If you found this helpful, please like and subscribe for more ISO 27001 control explainers. See you in the next video.